So some examples of logarithms. Here I have a quotient, so I am going to need to use the quotient rule. So the f dx is bottom. And then for the derivative of the top, it's a natural log already, so it's 1 over the inside times the derivative of the inside minus the top times the derivative of the bottom all over the bottom squared. Thank goodness we aren't required to simplify that. If I look at g of x here, I see that I'm going to have to use product rule, but I also see it's not a natural log. When no base is written like this is a common log. It's base 10. So this is x times the natural log of x squared over the natural log of 10, or I'm going to rewrite that to be 1 over the natural log of 10 times x times the natural log of x squared. I choose to write it that way because 1 over natural log of 10 is a constant multiple. So when I'm finding the derivative, it just kind of hangs out here waiting for everybody else. And in parentheses, I have to do the product rule now. So I have first times the derivative of natural log, which is 1 over the inside times the derivative of the inside, plus the second times derivative of the first, which is just 1. And I do need those parentheses to make sure all of that derivative is being multiplied by the 1 over natural log of 10. I've got a similar issue happening in h of x here. So I've got x squared plus x times 1 over the natural log of 3 times the natural log of x squared plus x. I'm going to pull that 1 over natural log of 3 out into the very front just to make my life a little bit easier. So now when I'm finding dh dx, the 1 over natural log of 3 is a constant multiple. Then parentheses, I need the product rule. So first, then derivative of the natural log is 1 over what's inside times the derivative of the inside plus second times the derivative of the first. And there are my derivatives.